Hello everyone and welcome to our today's session. For today the topic is AWS Certified DevOps Engineer Professional, that is DOP. So the first question is, a company has a mobile application that makes HTTP API calls to an application load balancer, that is ALB. The ALB routes requests to an AWS Lambda function. Many different versions of the application are in use at any given time, including versions that are in testing by a subset of users. The version of the application is defined in the user agent header that is sent with all requests to the API. After a series of recent changes to the API, the company has observed issues with the application. The company needs to gather a metric for each API operation by response code for each version of the application that is in use. A DevOps engineer has modified the Lambda function to extract the API operation name, version information from the user agent header, and response code. Question is, which additional set of actions should the DevOps engineer take to gather the required metrics? Options are A. Modify the Lambda function to write the API operation name, response code, and version number as a log line to an Amazon CloudWatch logs log group. Configure a CloudWatch logs metric filter that increments a metric for each API operation name. Specify response code and application version as dimensions for the metric. Option B. Modify the Lambda function to write the API operation name, response code, and version number as a log line to an Amazon CloudWatch logs CloudWatch logs log group. Configure a CloudWatch logs insights query to populate CloudWatch metrics from the log lines. Specify response cloud and application version as dimensions for the metric. Option C. Configure the ALB logs to write to an Amazon CloudWatch logs log group. Modify the Lambda function to respond to the ALB with the API operation name, response code, and version number as response metadata. Configure a CloudWatch logs metric filter that increments a metric for each API operation name. Specify response code and application version as dimensions for the metric. Last option is option D. Configure AWS X-ray integration on the Lambda function. Modify the Lambda function to create an X-ray subsegment with the API operation name, response code, and version number. Configure X-ray insights to extract an aggregated metric for each API operation name and to publish the metric to Amazon CloudWatch. Specify response code and application version as dimensions for the metric. So the correct answer is option B. Next question is, a company provides an application to customers. The application has an Amazon API, Gateway REST API that invokes an AWS Lambda function. On initialization, the Lambda function loads a large amount of data from an Amazon DynamoDB table. The data load process results in long cold start times of 8 to 10 seconds. The DynamoDB table has DynamoDB accelerated, that is DAX configured. Customers report that the application intermittently takes a long time to respond to requests. The application receives thousands of requests throughout the day. In the middle of the day, the application experiences 10 times more requests than at any other time of the day. Near the end of the day, the application's request volume decreases to 10% of its normal total. A DevOps engineer needs to reduce the latency of the Lambda function at all times of the day. So the question is, which solution will meet these requirements? So options are A. Configure provisioned concurrency on the Lambda function with a concurrency value of 1. Delete the DAX cluster for the DynamoDB table. Option B. Configure reserved concurrency on the Lambda function with a concurrency value of 0. Option C. Configure provisioned concurrency on the Lambda function. Configure AWS application to auto scaling on the Lambda function with provisioned concurrency values set to a minimum of 1 and maximum of 100. Option D. Configure reserved concurrency on the Lambda function. Configure AWS application auto scaling on the API gateway API with a reserved concurrency maximum value of 100. So, the correct answer is option C. Hello everyone and welcome back to our channel. So for today, our first question is here. A company is adopting AWS code deployed to automate its application deployments for a Java Apache Tomcat application with an Apache web server. The development team started with a proof of concept, created a deployment group for a developer environment, and performed functional tests within the application. After completion, the team will create additional deployment groups for staging and production. The current log level is configured within the Apache settings, but the team wants to change this configuration dynamically when the deployment occurs so that they can set different log level configurations depending on the deployment group without having a different applications revision for each group. So the question is, how can these requirements be met with the least management overhead and without requiring different script versions for each deployment group? Options are A. Tag the Amazon EC2 instances depending on the deployment group, then place a script into the application revision that calls the metadata service and the EC2 API to identify which deployment group the instance is part of. Use this information to configure the log level settings. Reference the script as part of the after install lifecycle hook in the appspec.yml file. Option B. Create a script that uses the code its environment variable deployment group name to identify which deployment group the instance is part of. Use this information to configure the log level settings. Reference this script as part of the before install lifecycle hook in the appspec.yml file. Option C. Create a code deploy custom environment variable for each environment. Then place a script into the application revision that checks this environment variable to identify which deployment group the instance is part of. Use this information to configure the log level settings. Reference the script as part of the validate service lifecycle hook in the appspec.yml file. Option D. Create a script that uses the code deploy environment variable deployment group ID to identify which deployment group the instance is part of to configure the log level settings. Reference this script as part of the install lifecycle hook in the appspec.yml file. So, the correct answer is option D. Next question is, a company requires its developers to tag all Amazon Elastic Block Store volumes in an account to indicate a desired backup frequency. This requirement includes EBS volumes that do not require backups. The company uses custom tags named backup frequency that have values of none, daily, or weekly that correspond to the desired backup frequency. An adult finds it's an audit finds that developers are occasionally not tagging the EBS volumes. A DevOps engineer needs to ensure that all EBS volumes always have the backup frequency tags so that the company can perform backups at least weekly unless a different value is specified. So the question is, which solution will meet these requirements? Options are A. Set up AWS config in the account. Create a custom rule that returns a compliance failure for all Amazon EC2 resources that do not have a backup frequency tag applied. Configure a remediation action that uses a custom AWS Systems Manager automation runbook to apply the backup frequency tag with a volume weekly. Option B. Set up AWS config in the account. Use a managed rule that returns a compliance failure for EC2 volume resources that do not have a backup frequency tag applied. Configure remediation action that uses a custom AWS Systems Manager automation runbook to apply the backup frequency tag with a value of weekly. Option C. Turn on AWS Cloud Trail in the account. Create an Amazon Event Bridge rule that reacts to EBS create volume events. Configure a custom AWS Systems Manager automation runbook to apply the backup frequency tag with a value of weekly. Specify the runbook as the target of the rule. Option D. Turn on AWS Cloud Trail in the account. Create an Amazon Event Bridge rule that reacts to EBS create volume events or EBS modify volume events. Configure a custom AWS Systems Manager automation runbook to apply the backup frequency tag with a value of weekly. Specify the runbook as the target of the rule. So the correct option is option B. Next question is, a company is using an Amazon Aurora cluster as the data store for its application. The Aurora cluster is configured with a single DB instance. The application performs read and write operations on the database by using the cluster's instance endpoint. The company has scheduled an update to be applied to the cluster during an upcoming maintenance window. The cluster must remain available with the least possible interruption during the maintenance window. What should a DevOps engineer do to meet these requirements? Options are A. Add a reader instance to the Aurora cluster. Update the application to use the Aurora cluster endpoint for write operations. Update the Aurora cluster's reader endpoint for reads. Option B. Add a reader instance to the Aurora cluster. Create a custom any endpoint for the cluster. Update the application to use the Aurora cluster's custom any endpoint for read and write operations. Option C. Turn on the multi-AZ option on the Aurora cluster. Update the application to use the Aurora cluster endpoint for write operations. Update the Aurora cluster's reader endpoint for reads. Option D. Turn on the multi-AZ option on the Aurora cluster. Create a custom any endpoint for the cluster. Update the application to use the Aurora cluster's custom any endpoint for read and write operations. So the correct answer is option C. That's all for today. Thank you everyone. And please do not forget to like and subscribe our channel. And if you find this video helpful, please let us know in comment box. That's all for today. Thank you everyone. Have a nice day. Hello everyone and welcome back to our channel. Today we will continue the session. So the question is, a company must encrypt all MIs that the company shares across accounts. A DevOps engineer has access to a source account where an unencrypted custom AMI has been built. The DevOps engineer also has access to a target account where an Amazon EC2 auto-scaling group will launch EC2 instances from the AMI. The DevOps engineer must share the AMI with the target account. The company has created an AWS key management service key in the source account. So the question is, which additional steps should the DevOps engineer perform to meet the requirements? Options are A. In the source account, copy the unencrypted AMI to an encrypted AMI. Specify the KMS key in the copy action. Option B. In the source account, copy the unencrypted AMI to an encrypted AMI. Specify the default Amazon Elastic Block Store encryption key in the copy action. Option C. In the source account, create an KMS grant that delegates permissions to the auto-scaling group service linked role in the target account. Option D. In the source account, modify the key policy to give the target account permissions to create a grant. In the target account, create a KMS grant that delegates permissions to the auto-scaling group service linked role. Option E. In the source account, share the unencrypted AMI with the target account. Option F. In the source account, share the encrypted AMI with the target account. So, the correct answer is option A, D, and F. Next question is, a company uses AWS code pipelines to automate in releases of its application. A typical pipeline consists of three stages: build, test, and deployment. The company has been using a separate AWS code build project to run scripts for each stage. However, the company now wants to use AWS Code Deploy to handle the deployment stage of the pipelines. The company has packaged the application as an RPM package and must deploy the application to a fleet of Amazon EC2 instances. The EC2 instances are in an EC2 auto-scaling group and are launched from a common AMI. So the question is, which combinations of steps should a DevOps engineer perform to meet these requirements? Options are: A. Create a new version of the common AMI with the code deploy agent installed. Update the AMI role of the EC2 instances to allow access to code deploy. Option B. Create a new version of the common AMI with the code deploy agent installed. Create an app spec file that contains application deployment scripts and grants access to the code deploy. Option C. Create an application in code deploy. Configure an in-place deployment type. Specify the auto scaling group as the deployment target. Add a step to the code pipeline to use EC2 image builder to create a new AMI. Configure code deploy to deploy the newly created AMI. Option D. Create an application in the code deploy. Configure an in-place deployment type. Specify the auto-scaling group as the deployment target. Update the code pipeline to use the code deploy action to deploy the application. Option E. Create an application in code deploy. Configure an in-place deployment type. Specify the EC2 instances that are launched from the common AMI as the deployment target. Update the code pipeline to use the code deploy action to deploy the application. So the correct answer is option A and D. Next question is, a company's security team requires that all external application load balancers, that is ALB, and Amazon API gateway APIs are associated with AWS WAF web ALCs. The company has hundreds of AWS accounts, all of which are included in a single organization in AWS organizations. The company has configured AWS config for the organization. During an audit, the company finds some externally facing ALBs that are not associated with AWS WF Web ALCs. So the question is, which combination of steps should a DevOps engineer take to prevent future violations? Options are: A. Delegate AWS Firewall Manager to a security account. Option B. Delegate Amazon Guard Duty to a security account. Option C. Create an AWS Firewall Manager policy to attach AWS WAF Web ALCs to any newly created ALBs and API Gateway APIs. Option D. Create an Amazon Guard Duty policy to attach AWS WF Web ALCs to any newly created ALBs and API Gateway APIs. Option E. Configure an AWS config managed rule to attach AWS WF Web ALCs to any newly created ALBs and API Gateway APIs. So, the correct answer is C and E. Next question is, a company uses AWS Key Management Service, keys and manual key rotation to meet regulatory compliance requirements. The security team wants to be notified when any keys have not been rotated after 90 days. So question is, which solution will accomplish this? Options are: A. Configure AWS KMS to publish to an Amazon simple notification service topic when keys are more than 90 days old. Option B. Configure an Amazon Event Bridge event to launch an AWS Lambda function to call the AWS Trusted Advisor API and publish to an Amazon simple notification service topic. Option C. Develop an AWS config custom rule to that publishes to an Amazon simple notification service topic when keys are more than 90 days old. Option D. Configure AWS Security Hub to publish to an Amazon simple notification service topic when keys are more than 90 days old. So the correct answer is option C. That's all for today. Thank you everyone, and please do not forget to like and subscribe our channel. Hello everyone, welcome back to our channel. So today we will continue our session. The question is, a security review has identified that an AWS code build project is downloading a database population script from an Amazon S3 bucket using an unauthenticated request. The security team does not allow unauthenticated requests to S3 buckets for this project. So the question is, how can this issue be corrected in the most secure manner? Options are A. Add the bucket name to the allowed bucket section of the code build project settings. Update the build spec to use the AWS CLI to download the database population script. Option B. Modify the S3 bucket settings to enable HTTPS basic authentication and specify a token. Update the build spec to use URL to pass this token and download the database population script. Option C. Remove unauthenticated access from the S3 bucket with a bucket policy. Modify the service role for the code build project to include Amazon's S3 access. Use the AWS CLI to download the database population script. Option D. Remove unauthenticated access from the S3 bucket with a bucket policy. Use the AWS CLI to download the database population script using an IAM access key and a secrets access key. So the correct answer is option C. Next question is, an e-commerce company has chosen AWS to host its new platform. The company's DevOps team has started building an AWS controlled tower landing zone. The DevOps team has set the identity store within AWS IAM Identity Center to external identity provider and has configured SAML 2.0. The DevOps team wants a robust permission model that applies the principle of least privilege. The model must allow the team to build and manage only the team's own resources. So the question is, which combination of steps will meet these requirements? Options are A. Create IAM policies that include the required permissions. Include the AWS principal tag condition key. Option B. Create permission sets. Attach an inline policy that includes the required permissions and uses the AWS principal tag condition key to scope the permissions. Option C. Create a group in the IDP. Place users in the group. Assign the group to accounts and the permission sets in IAM Identity Center. Option D. Create a group in the IDP. Place users in the group. Assign the group to OUS and IAM policies. Option E. Enable attributes for access control in IAM Identity Center. Apply tags to users. Map the tags as key value pairs. Option F. Enable attributes for access control in IAM Identity Center. Map attributes from the IDP as key value pairs. So the correct answer is options A, B, C and F. Next question is, an e-commerce company is receiving reports that its order history page is experiencing delays in reflecting the processing status of orders. The order processing system consists of an AWS Lambda function that uses reserved concurrency. The Lambda function processes order messages from an Amazon simple queue service queue and inserts processed orders into an Amazon DynamoDB table. The DynamoDB table has auto scaling enabled for read and write capacity. So the question is, which actions should a DevOps engineer take to resolve this delay? So the options are A. Check the approximate age of oldest message metric for the SQS queue. Increase the Lambda function concurrency limit. Option B. Check the approximate age of oldest message metric for the SQS queue. Configure a rewrite policy on the SQS queue. Option C. Check the number of messages sent metric for the SQS queue. Increase the SQS queue visibility timeout. Option D. Check the write throttle events metric for the DynamoDB table. Increase the maximum write capacity units for the table's scaling policy. Option E. Check the throttles metric for the Lambda function. Increase the Lambda function timeout. So the correct answer is option A and D. Next question is, a company has a single AWS account that runs hundreds of Amazon EC2 instances in a single AWS region. New EC2 instances are launched and terminated each hour in the account. The account also includes existing EC2 instances that have been running for longer than a week. The company's security policy requires all running EC2 instances to use an EC2 instance profile. If an EC2 instance does not have an instance profile attached, the EC2 instance must use a default instance profile that has no IAM permissions assigned. A DevOps engineer reviews the account and discovers EC2 instances that are running without an instance profile. During this review, the DevOps engineer also observes that new EC2 instances are being launched without an instance profile. So the question is, which solution will ensure that an instance profile is attached to all existing and future EC2 instances in the region? Options are A. Configure an Amazon Event Bridge rule that reacts to EC2 run instances API calls. Configure the rule to invoke an AWS Lambda function to attach the default instance profile to the EC2 instances. Option B. Configure the EC2 instance profile attached AWS config managed rule with a trigger type of configuration changes. Configure an automatic remediation action that invokes an AWS Systems Manager automation runbook to attach the default instance profile to the EC2 instances. Option C. Configure an Amazon Event Bridge rule that reacts to EC2 start instances API calls. Configure the rule to invoke an AWS Systems Manager automation runbook to attach the default instance profile to the EC2 instances. Option D. Configure the IAM role managed policy check AWS config managed rule with a trigger type of configuration changes. Configure an automatic remediation action that invokes an AWS Lambda function to attach the default instance profile to the EC2 instances. So, the correct answer is option B. Next question is, a DevOps engineer is building a continuous deployment pipeline for a serverless application that uses AWS Lambda functions. The company wants to reduce the customer impact of an unsuccessful deployment. The company also wants to monitor for issues. So the question is, which deploy stage configuration will meet these requirements? Options are A. Use an AWS Serverless Application Model template to define the serverless application. Use AWS Code Deploy to deploy the Lambda functions with the Canary 10% 15 minutes deployment preference type. Use Amazon CloudWatch alarms to monitor the health of the functions. Option B. Use AWS CloudFormation to publish a new stack update and include Amazon CloudWatch alarms on all resources. Set up an AWS code pipeline approval action for a developer to verify and approve the AWS CloudFormation chain set. Option C. Use AWS CloudFormation to publish a new version on every stack update and include Amazon CloudWatch alarms on all resources. Use the routing config property of the AWS Lambda Alliance resource to update the traffic routing during the stack update. Option D. Use AWS code build to add sample event payloads for testing to the Lambda functions. publish a new version of the functions and include Amazon CloudWatch alarms, update the production alias to point to the a new version, configure rollbacks to occur when an alarm is in the alarm set state. So the correct answer is option A. Next question is, to run an application, a DevOps engineer launches an Amazon EC2 instance with public IP addresses in a public subnet. A user data script obtains the application artifacts and installs them on the instances upon launch. A change to the security classification of the application now requires the instances to run with no access to the internet. While the instance is launched successfully and show as healthy, the application does not seem to be installed. So the question is, which of the following should successfully install the application while complying with the new rule? Options are A. Launch the instances in a public subnet with elastic IP addresses attached. Once the application is installed and running, run a script to disassociate the elastic IP addresses afterwards. Option B. Set up a NAT gateway, deploy the EC2 instances to a private subnet, update the private subnet's root table to use the NAT gateway as the default root. Option C. Publish the application artifacts to an Amazon S3 bucket and create a VPC endpoint for S3. Assign an IAM instance profile to the EC2 instances so they can read the application artifacts from the S3 bucket. Option D. Create a security group for the application instances and allow only outbound traffic to the artifact repository. Remove the security group rule once the install is complete. So the correct answer is option B. That's all for today. Thank you everyone, and please do like and subscribe to our channel. Hello everyone. Welcome back to our channel. Today we will continue the last session. So, question is, a development team is using AWS code commit to version control application code and AWS code pipeline to orchestrate software deployments. The team has decided to use a remote main branch as the trigger for the pipeline to integrate code changes. A developer has pushed code changes to the commit repository but noticed that the pipeline had no reaction even after 10 minutes. So the question is, which of the following actions should be taken to troubleshoot this issue? Options are A. Check that an Amazon event bridge rule has been created for the main branch to trigger the pipeline. Option B. Check that the code pipeline service role has permission to access the code commit repository. Option C. Check that the developer's IAM role has permission to push to the code commit repository. Option D. Check to see if the pipeline failed to start because of code commit errors in Amazon CloudWatch logs. So the correct answer is option A. Next question is, a company's developers use Amazon EC2 instances as remote workstations. The company is concerned that users can create or modify EC2 security groups to allow unrestricted inbound access. A DevOps engineer needs to develop a solution to detect when users create unrestricted security group rules. The solution must detect changes to security group rules in near real time, remove unrestricted rules, and send email notifications to the security team. The DevOps engineer has created an AWS Lambda function that checks for security group ID from input, removes rules that grant unrestricted access, and send notifications through Amazon Simple Notification Service. So the question is, what should the DevOps engineer do next to meet these requirements? Options are A. Configure the Lambda function to be invoked by the SNS topic. Create an AWS CrowdTrail subscription for the SNS topic. Configure a subscription filter for security group modification events. Option B. Create an Amazon Event Bridge schedule rule to invoke the Lambda function. Define a schedule pattern that runs the Lambda function every hour. Option C. Create an Amazon Event Bridge event rule that has the default event bus as the source. Define the rules event pattern to match EC2 security group creation and modification events. Configure the rule to invoke the Lambda function. Option D. Create an Amazon Event Bridge custom event bus that subscribes to events from all AWS services. Configure the Lambda function to be invoked by the custom event bus. So the correct answer is option C. Next question is, a DevOps engineer is creating an AWS CloudFormation template to deploy a web service. The web service will run on Amazon EC2 instances in a private subnet behind an application load balancer. The DevOps engineer must ensure that the service can accept requests from clients that have IPv6 addresses. So the question is, what should the DevOps engineer do with the CloudFormation template so that IPv6 clients can access the web service? Options are A. Add an IPv6 CIDR block to the VPC and the private subnet for the EC2 instances. Create route table entries for the IPv6 network. Use EC2 instances types that support IPv6 and assign IPv6 addresses to each EC2 instance. Option B. Assign each EC2 instance an IPv6 elastic IP address. Create a target group and add the EC2 instances as targets. Create a listener on port 443 of the ALB and associate the target group with the ALB. Option C. Replace the ALB with a network load balancer, that is NLB. Add an IPv6 CIDR block to the VPC and subnets for the NLB and assign the NLB an IPv6 elastic IP address. Option D. Add an IPv6 CIDR block to the VPC and subnets for the ALB. Create a listener on port 443 and specify the doll stack IP address type on the ALB. Create a target group and add the EC2 instances as targets. Associate the target group with the ALB. So the correct answer is option D. Next question is, a company uses AWS organizations and AWS control tower to manage all the company's AWS accounts. Next question is, a company uses AWS organizations and AWS control tower to manage all the company's AWS accounts. The company uses the enterprise support plan. A DevOps engineer is using account factory for Terraform, that is AFT, to provision new accounts. When new accounts are provisioned, the DevOps engineer notices that the support plan for the new accounts is set to the basic support plan. The DevOps engineer needs to implement a solution to provision the new accounts with the enterprise support plan. So the question is, which solution will meet these requirements? Options are A. Use an AWS config conformance pack to deploy the account part of organization's AWS config rule and to automatically remediate any non-compliant accounts. Option B. Create an AWS Lambda function to create a ticket for AWS support to add the account to the enterprise support plan. Grant the Lambda function the support resolve case permission. Option C. Add an additional value to the control tower parameters input to set the AWS enterprise support parameter as the organization's management account number. Option D. Set the AFT feature enterprise support feature flag to true in the AFT deployment input configuration. Redeploy AFT and apply the changes. So the correct answer is option D. Next question is, a company's DevOps engineer uses AWS Systems Manager to perform maintenance tasks during maintenance windows. The company has a few Amazon EC2 instances that require a restart after notifications from AWS Health. The DevOps engineer needs to implement an automated solution to remediate these notifications. The DevOps engineer creates an Amazon Event Bridge rule. So the question is, how should the DevOps engineer configure the event bridge rule to meet these requirements? Options are A. Configure an event source of AWS Health, a service of EC2, and an event type that indicates instance maintenance. Target a systems manager document to restart the EC2 instance. Option B. Configure an event source of Systems Manager and an event type that indicates a maintenance window. Target a Systems Manager document to restart the EC2 instance. Option C. Configure an event source of AWS Health, a service of EC2, and an event type that indicates instance maintenance. Target a newly created AWS Lambda function that registers an automation task to restart the EC2 instance during a maintenance window. Option D. Configure an event source of EC2 and an event type that indicates instance maintenance. Target a newly created AWS Lambda function that registers an automation task to restart the EC2 instance during a maintenance window. So the correct answer is option C. Next question is, a company has containerized all of its in-house quality control applications. The company is running Jenkins on Amazon EC2 instances which require patching and upgrading. The compliance officer has requested a DevOps engineer begin encrypting build artifacts since they contain company intellectual property. So the question is, what should the DevOps engineer do to accomplish this in the most maintainable manner? Options are A. Automate patching and upgrading using AWS Systems Manager on EC2 instances and encrypt Amazon EBS volumes by default. Option B. Deploy Jenkins to an Amazon ECS cluster and copy build artifacts to an Amazon S3 bucket with default encryption enabled. Option C. Leverage AWS code pipeline with a build action and encrypt the artifacts using AWS Secrets Manager. Option D. Use AWS code built with artifact encryption to replace the Jenkins instance running on EC2 instances. So the correct answer is option B. Next question is, an IT team has built an AWS CloudFormation template so others in the company can quickly and reliably deploy and terminate an application. The template creates an Amazon EC2 instance with a user data script to install the application and an Amazon S3 bucket that the application uses to serve static web pages while it is running. All resources should be removed when the CloudFormation stack is deleted. However, the team observes that CloudFormation reports an error during stack deletion and the S3 bucket created by the stack is not deleted. So the question is, how can the team resolve the error in the most efficient manner to ensure that all resources are deleted without errors? Options are A. Add a Deletion policy attribute to the S3 bucket resource with the value delete, forcing the bucket to be removed when the stack is deleted. Option B. Add a custom resource with an AWS Lambda function with the depends on attribute specifying the S3 bucket and an IAM role. Write the Lambda function to delete all objects from the bucket when request type is delete. Option C. Identify the resource that was not deleted, manually empty the S3 bucket and then delete it. Option D. Replace the EC2 and S3 bucket resources with a single AWS OpsWorks stacks resource. Define a custom recipe for the stack to create and delete the EC2 instance and the S3 bucket. So the correct answer is option B. That's all for today. Thank you everyone. And please do not forget to like and subscribe our channel. If Hello everyone and welcome back to our channel. So we will continue the session today. The question is, a company has an AWS code pipeline that is configured with an Amazon S3 bucket in the EU West 1 region. The pipeline deploys an AWS Lambda application to the same region. The pipeline consists of an AWS code build project build action and an AWS CloudFormation deploy action. The code build project uses the AWS CloudFormation package AWS CLI command to build an artifact that contains the Lambda function code's zip file and the CloudFormation template. The CloudFormation deploy action references the CloudFormation template from the output artifact of the code build project's build action. The company wants to also deploy the Lambda application to the US East 1 region by using the pipeline in EU West 1. A DevOps engineer has already updated the code build project to use the AWS CloudFormation package command to produce an additional output artifact for US East 1. So the question is, which combination of additional steps should the DevOps engineer take to meet these requirements? Options are A. Modify the CloudFormation template to include a parameter for the Lambda function code's zip file location. Create a new CloudFormation deploy action for US East 1 in the pipeline. Configure the new deploy action to pass in the US East 1 artifact location as a parameter override. Option B. Create a new CloudFormation deploy action for US East 1 in the pipeline. Configure the new deploy action to use the CloudFormation template from the US East 1 output artifact. Option C. Create an S3 bucket in US East 1. Configure the S3 bucket policy to allow code pipeline to have read and write access. Option D. Create an S3 bucket in US East 1. Configure S3 cross-region replication from the S3 bucket in EU West 1 to the S3 bucket in US East 1. Option E. Modify the pipeline to include the S3 bucket for US East 1 as an artifact store. Create a new CloudFormation deploy action for US East 1 in the pipeline. Configure the new deploy action to use the CloudFormation template from the US East 1 output artifact. So, the correct answer is option A and E. Next question is, a company runs an application on one Amazon EC2 instance. Application metadata is stored in Amazon S3 and must be retrieved if the instance is restarted. The instance must restart or relaunch automatically if the instance becomes unresponsive. So the question is, which solution will meet these requirements? Options are A. Create an Amazon CloudWatch alarm for the status check failed metric. Use the recover action to stop and start the instance. Use an S3 event notification to push the metadata to the instance when the instance is back up and running. Option B. Configure AWS OpsWorks and use the auto healing feature to stop and start the instance. Use a lifecycle event in OpsWorks to pull the metadata from Amazon S3 and update it on the instance. Option C. Use EC2 auto recovery to automatically stop and start the instance in case of a failure. Use an S3 event notification to push the metadata to the instance when the instance is back up and running. Option D. Use AWS CloudFormation to create an EC2 instance that includes the user data property for the EC2 resource. Add a command in user data to retrieve the application metadata from Amazon S3. So the correct answer is option C. Next question is, a company hosts a security auditing application in an AWS account. The auditing application uses an IAM role to access other AWS accounts. All the accounts are in the same organization in AWS organizations. A recent security audit revealed that users in the audited AWS accounts could modify or delete the auditing application's IAM role. The company needs to prevent any modification to the auditing application's IAM role by any entity other than a trusted administrator IAM role. So the question is, which solution will meet these requirements? Options are A. Create an SCP that includes a deny statement for changes to the auditing application's IAM role. Include a condition that allows the trusted administrator IAM role to make changes. Attach the SCP to the root of the organization. Option B. Create an SCP that includes an allow statement for changes to the auditing application's IAM role by the trusted administrator IAM role. Include a deny statement for changes by all other IAM principals. Attach the SCP to the IAM service in each AWS account where the auditing application has an IAM role. Option C. Create an IAM permissions boundary that includes a deny statement for changes to the auditing application's IAM role. Include a condition that allows the trusted administrator IAM role to make changes. Attach the permissions boundary to the audited AWS accounts. Option D. Create an IAM permissions boundary that includes a deny statement for changes to the auditing application's IAM role. Include a condition that allows the trusted administrator IAM role to make changes. Attach the permissions boundary to the auditing application's IAM role in the AWS accounts. So the correct answer is option C. Next question is, a company has an on-premises application that is written in Go. A DevOps engineer must move the application to AWS. The company's development team wants to enable blue or green deployments and perform A or B testing. So the question is, which solution will meet these requirements? Options are A. Deploy the application on an Amazon EC2 instance and create an AMI of the instance. Use the AMI to create an automatic scaling launch configuration that is used in an auto scaling group. Use elastic load balancing to distribute traffic. When changes are made to the application, a new AMI will be created which will initiate an EC2 instance refresh. Option B. Use Amazon Lightsail to deploy the application. Store the application in a zipped format in an Amazon S3 bucket. Use this zipped version to deploy new versions of the application to Lightsail. Use Lightsail deployment options to manage the deployment. Option C. Use AWS Code Artifact to store the application code. Use AWS Code Deploy to deploy the application to a fleet of Amazon EC2 instances. Use elastic load balancing to distribute the traffic to the EC2 instances. When making changes to the application, upload a new version to Code Artifact and create a new code deploy deployment. Option D. Use AWS Elastic Beanstalk to host the application. Store a zipped version of the application in Amazon S3. Use that location to deploy new versions of the application. Use Elastic Beanstalk to manage the deployment options. So the correct answer is option C. Thank you everyone. That's all today. And everyone, please do like and subscribe to our channel. If you find this video helpful, please let us know in the comment box. Thank you. Hello everyone and welcome back to our channel. So for today the question is, a developer is maintaining a fleet of 50 Amazon EC2 Linux servers. The servers are part of an Amazon EC2 auto scaling group and also use elastic load balancing for load balancing. Occasionally some application servers are being terminated after failing ELB HTTP health checks. The developer would like to perform a root cause analysis on the issue, but before being able to access application logs, the server is terminated. So the question is, how can log collection be automated? Options are: use auto-scaling lifecycle hooks to put instances in a pending wait state, create an Amazon CloudWatch alarm for EC2 instance terminate successful, and trigger an AWS Lambda function that invokes an SSM run compound script to collect logs, push them to Amazon S3, and complete the lifecycle action once logs are collected. Option B. Use autoscaling lifecycle hooks to put instances in a terminating wait state. Create an AWS config rule for EC2 instance terminate lifecycle action and trigger a step function that invokes a script to collect logs, push them to Amazon S3, and complete the lifecycle action once logs are collected. Option C. Use auto-scaling lifecycle hooks to put instances in a terminating wait state. Create an Amazon CloudWatch subscription, filter for EC2 instance terminates successful, and trigger a CloudWatch agent that invokes a script to collect logs, push them to Amazon S3, and complete the lifecycle action once logs are collected. Option D. Use auto-scaling lifecycle hooks to put instances in a terminating wait state. Create an Amazon event bridge rule for EC2 instance terminate lifecycle action and trigger an AWS Lambda function that invokes an SSM run command script to collect logs. push them to Amazon S3 and complete the lifecycle action once logs are collected. So the answer is option D. Next question is, a company has an organization in AWS organizations. The organization includes workload accounts that contain enterprise applications. The company centrally manages users from an operations account. No users can be created in the workload accounts. The company recently added an operations team and must provide the operations team members with administrator access to each workload account. So the question is, which combination of actions will provide this access? Option A, create a sysadmin role in the operations account, attach the administrator access policy to the role, modify the trust relationship to allow the STS assume role action from the workload accounts. Option B, create a sysadmin role in each workload account, attach the administrator access policy to the role, modify the trust relationship to allow the STS assume role action for the operations account. Option C, create an Amazon Cognito identity pool in the operations account. Attach the sysadmin role as an authenticated role. Option D, in the operations account, create an IAM user for each operations team member. Option E, in the operations account, create an IAM user group that is named sysadmins. Add an IAM policy that allows the STS assume role action for the sysadmin role in each workload account. Add all operations team members to the group. Option F, create an Amazon Cognito user pool in the operations account. Create an Amazon Cognito user for each operations team member. So the correct answer is option A, B, and E. Next question is, a company has multiple accounts in an organization in AWS organizations. The company's SecOps team needs to receive an Amazon Simple Notification Service notification if any account in the organization turns off the block public access feature on an Amazon S3 bucket. A DevOps engineer must implement this change without affecting the operation of any AWS accounts. The implementation must ensure that individual member accounts in the organization cannot turn off the notification. So the question is, which solution will meet these requirements? Options are A, designate an account with a delegated Amazon Guard Duty Administrator account. Turn on Guard Duty for all accounts across the organization. In the Guard Duty Administrator account, create a SNS topic. Subscribe the SecOps team's email address to the SNS topic. In the same account, create an Amazon Event Bridge rule that uses an event pattern for guard duty findings and a target of the SNS topic. Option B, create an AWS CloudFormation template that creates an SNS topic and subscribes the SecOps team's email address to the SNS topic. In the template, include an Amazon Event Bridge rule that uses an event pattern of CloudTrail activity for S3, put bucket public access block, and a target of the SNS topic. Deploy the stack to every account in the organization by using CloudFormation stack sets. It's stack sets. Option C, turn on AWS config across the organization. In the delegated administrator account, create an SNS topic. Subscribe the SecOps team's email address to the SNS topic. Deploy a conformance pack that uses the S3 bucket level public access prohibited AWS config managed rule in each account and uses an AWS systems manager document to publish each account and uses an AWS Systems Manager document to publish an event to the SNS topic to notify the SecOps team. Option D, turn on Amazon Inspector across the organization. In the Amazon Inspector delegated administrator account, create an SNS topic. Subscribe the SecOps team's email address to the SNS topic. In the same account, create an Amazon Event Bridge rule that uses an event pattern for public network exposure of the S3 bucket and publishes an event to the SNS topic to notify the SecOps team. So the correct answer is option C. Next question is, a company has migrated its container-based applications to Amazon EKS and want to establish automated email notifications. The notifications sent to each email address are for specific activities related to EKS components. The solution will include Amazon SNS topics and an AWS Lambda function to evaluate incoming log events and publish messages to the correct NSS topic. So the question is, which logging solution will support these requirements? Options are A. Enable Amazon CloudWatch logs to log the EKS components. Create a CloudWatch subscription filter for each component with Lambda as the subscription feed destination. Option B. Enable Amazon CloudWatch logs to log the EKS components. Create CloudWatch logs inside queries linked to Amazon Event Bridge events that invoke Lambda. Option C. Enable Amazon S3 logging for the EKS components. Configure an Amazon CloudWatch subscription. Filter for each component with Lambda as a subscription feed destination. Option D. Enable Amazon S3 logging for the EKS components. Configure S3 put object, event, or notification with AWS Lambda as the destination. So the correct answer is option A. Hello everyone and welcome back to our channel. So for today's session, the question is, a company is implementing an Amazon Elastic Container Service cluster to run its workload. The company architecture will run multiple ECS services on the cluster. The architecture includes an application load balancer on the front end and uses multiple target groups to route traffic. A DevOps engineer must collect application and access logs. The DevOps engineer then needs to send the logs to an Amazon S3 bucket for near real time analysis. So the question is, which combination of steps must the DevOps engineer take to meet these requirements? Options are A. Download the Amazon CloudWatch Logs container instance from AWS. Configure this instance as a task. Update the application service definitions to include the logging task. Option B. Install the Amazon CloudWatch Logs agent on the ECS instances. Change the logging driver in the ECS task definition to AWS Logs. Option C. Use Amazon Event Bridge to schedule an AWS Lambda function that will run every 60 seconds and will run the Amazon CloudWatch logs create export task command. Then point the output to the logging S3 bucket. Option D. Activate access logging on the ALB. Then point the ALB directly to the logging S3 bucket. Option E. Activate access logging on the target groups that the ECS services use, then send the logs directly to the logging S3 bucket. Option F. Create an Amazon Kinesis data Firehose delivery stream that has the destination of the logging S3 bucket. Then create an Amazon CloudWatch logs subscription filter for Kinesis data Firehose. So the correct answer is options B, E, and F. Next question is, a company that uses electronic health records is using a fleet of Amazon EC2 instances with an Amazon Linux operating system. As part of patient privacy requirements, the company must ensure continuous compliance for patches for operating system and appliances running on the EC2 instances. So the question is, how can the deployments of the operating system and application patches be automated using a default and custom repository? Options are A. Use AWS Systems Manager to create a new patch baseline including the custom repository. Run the AWS Run Patch Baseline document using the run command to verify and install patches. Option B. Use AWS Direct Connect to integrate the corporate repository and deploy the patches using Amazon CloudWatch scheduled events, then use the CloudWatch dashboard to create reports. Option C. Use yum config manager to add the custom repository under etc. yum report and run yum config manager enable to activate the repository. Option D. Use AWS Systems Manager to create a new patch baseline including the corporate repository. Run the AWS Amazon Linux default patch baseline document using the run command to verify and install patches. So the correct answer is option D. Next question is, a company is using AWS Code Pipeline to automate its release pipeline. AWS Code Deploy is being used in the pipeline to deploy an application to Amazon Elastic Container Service using the blue or green deployment model. The company wants to implement scripts to test the green version of the application before shifting traffic. These scripts will complete in 5 minutes or less. If errors are discovered during these tests, the application must be rolled back. So the question is, which strategy will meet these requirements? Options are A. Add a stage to the code pipeline between the source and deploy stages. Use AWS code build to create a runtime environment and build commands in the build spec file to invoke test scripts. If errors are found, use the AWS deploy stop deployment command to stop the deployment. Option B. Add a stage to the code pipeline between the source and the deploy stages. Use this stage to invoke an AWS Lambda function that will run the test scripts. If errors are found, use the AWS deploy stop deployment command to stop the deployment. Option C. Add a hook section to the code deploy app spec file. Use the after allow test traffic lifecycle event to invoke an AWS Lambda function to run the test scripts. If errors are found, exit the Lambda function with an error to initiate rollback. Option D. Add a hook section to the code deploy app spec file. Use the after allow traffic lifecycle event to invoke the test scripts. If errors are found, use the AWS deploy stop deployment CLI command to stop the deployment. So, the correct answer is option C. Next question is, a company uses AWS storage gateway in file gateway mode in front of an Amazon S3 bucket that is used by multiple resources. In the morning when business begins, users do not see the objects processed by a third party the previous evening. When a DevOps engineer looks directly at the S3 bucket, the data is there, but it is missing in storage gateway. So the question is, which solution ensures that all the updated third party files are available in the morning? So the options are A. Configure nightly Amazon event bridge event to invoke an AWS Lambda function to run the refresh catch command for storage gateway. Option B. Instruct the third party to put data into the S3 bucket using AWS transfer for SFTP. Option C. Modify storage gateway to run in volume gateway mode. Option D. Use S3 same region replication to replicate any changes made directly in the S3 bucket to storage gateway. So the correct answer is option A. Next question is, a DevOps engineer needs to back up sensitive Amazon S3 objects that are stored within an S3 bucket with a private bucket policy using S3 cross-region replication functionality. The objects need to be copied to a target bucket in a different AWS region and account. So the question is, which combination of actions should be performed to enable this replication? Options are A. Create an application IAM role in the source account. Option B. Create a replication IAM role in the target account. Option C. Add statements to the source bucket policy, allowing the replication IAM role to replicate objects. Option D. Add statements to the target bucket policy, allowing the replication IAM role to replicate objects. Option E. Create a replication rule in the source bucket to enable the replication. Option F. Create a replication rule in the target bucket to enable the replication. So the correct answer is options A, C and D. That's all for today. Thank you everyone. And please do like and subscribe to our channel. Our team is working really hard to keep the content up to date. And if you find this video helpful, please let us know in the comment box. Thank you everyone. Hello everyone and welcome back to our channel. Today we will continue our session, but before that please do like and subscribe to our channel. If you find this video helpful, please let us know in the comment box. So the question is, a company has multiple member accounts that are part of an organization in AWS organizations. The security team needs to review every Amazon EC2 security group and their inbound and outbound rules. The security team wants to programmatically retrieve this information from the member accounts using an AWS Lambda function in the management account of the organization. So the question is, which combination of access changes will meet these requirements? Options are A. Create a trust relationship that allows users in the member accounts to assume the management account IAM role. Option B. Create a trust relationship that allows users in the management account to assume the IAM roles of the member accounts. Option C, create an IAM role in each member account that has access to the Amazon EC2 read-only access managed policy. Option D, create an IAM role in each member account to allow the STS assume role action against the management account IAM roles ARN. Option E, create an IAM role in the management account that allows the STS assume role action against the member account IAM roles ARN. Option F, create an IAM role in the management account that has access to the Amazon EC2 read-only access managed policy. So the correct answer is option A, C and E. Next question is, a space exploration company receives telemetry data from multiple satellites. Small packets of data are received through Amazon API gateway and are placed directly into an Amazon Simple Queue service standard queue. A custom application is subscribed to the queue and transforms the data into a standard format. Because of inconsistencies in the data that the satellites produce, the application is occasionally unable to transform the data. In these cases, the messages remain in the SQS queue. A DevOps engineer must develop a solution that retains the failed messages and makes them available to scientists for review and future processing. So the question is, which solution will meet these requirements? Options are A, configure AWS Lambda to poll the SQS queue and invoke a Lambda function to check whether the queue messages are valid. If validation fails, send a copy of the data that is not valid to an Amazon S3 bucket so that the scientists can review and correct the data. When the data is corrected, amend the message in the SQS queue by using a replay Lambda function with the corrected data. Option B, convert the SQS standard queue to an SQS FIFO queue. Configure AWS Lambda to poll the SQS queue every 10 minutes by using an Amazon Event Bridge schedule. Invoke the Lambda function to identify any messages with a sent timestamp value that is older than 5 minutes. Push the data to the same location as the application's output location and remove the messages from the queue. Option C, create an SQS dead letter queue. Modify the existing queue by including a retry policy that sets the maximum receive setting to 1 and sets the dead letter queue ARN to the ARN of the newly created queue. Instruct the scientists to use the dead letter queue to review the data that is not valid. Reprocess this data at a later time. Option D, configure API gateway to send messages to different SQS virtual queues that are named for each of the satellites. Update the application to use a new virtual queue for any data that it cannot transform and send the message to the new virtual queue. Instruct the scientists to use the virtual queue to review the data that is not valid. Reprocess this data at a later time. So the correct answer is option C. Next question is, a company wants to use AWS CloudFormation for infrastructure deployment. The company has strict tagging and resource requirements and wants to limit the deployment to 2 reasons. Developers will need to deploy multiple versions of the same application. So the question is, which solution ensures resources are deployed in accordance with company policy? Options are A, create AWS Trusted Advisor checks to find and remediate unapproved CloudFormation stack sets. Option B, create a CloudFormation drift detection operation to find and remediate unapproved CloudFormation stack sets. Option C, create CloudFormation stack sets with approved CloudFormation templates. Option D, create AWS Service Catalog products with approved CloudFormation templates. So the correct answer is option C. Next question is, a company requires that its internally facing web application be highly available. The architecture is made up of one Amazon EC2 web server instance and one NAT instance that provides outbound internet access for updates and accessing public data. So question is, which combination of architecture adjustments should the company implement to achieve high availability? So options are A, add the NAT instance to an EC2 auto-scaling group that spans multiple availability zones. Update the root tables. Option B, create additional EC2 instances spanning multiple availability zones. Add an application load balancer to split the load between them. Option C, configure an application load balancer in front of the EC2 instance. Configure Amazon CloudWatch alarms to recover the EC2 instance upon host failure. Option D, replace the NAT instance with a NAT gateway in each availability zone. Update the root tables. And option E, replace the NAT instance with a NAT gateway that spans multiple availability zones, update the route tables. So the correct answer is option B and E. Next question is, a DevOps engineer is building a multi-stage pipeline with AWS code pipeline to build, verify stage, test and deploy an application. A manual approval stage is required between the test stage and the deploy stage. The development team uses a custom chat tool with webhook support that requires near real-time notifications. So the question is, how should the DevOps engineer configure status updates for pipeline activity and approval requests to post the chat tool? Options are A. Create an Amazon CloudWatch log subscription that filters on code pipeline execution, state change. Publish subscription events to an Amazon Simple Notification Service topic. Subscribe the chat webhook URL to the SNS topic and complete the subscription validation. Option B. Creates an AWS Lambda function that is invoked by AWS CloudTrail events. When a code pipeline execution state change event is detected, send the event details to the chat webhook URL. Option C. Create an Amazon event bridge rule that filters on code pipeline execution state change. Publish the events to an Amazon Simple Notification Service topic. Create an AWS Lambda function that sends event details to the chat webhook URL. Subscribe the function to the SNS topic. Option D. Modify the pipeline code to send the event details to the chat webhook URL at the end of each stage. Parameterize the URL so that each pipeline can send to a different URL based on the pipeline environment. So the correct answer is option A. That's all for today. Thank you everyone, and please do not forget to like and subscribe our channel. Our team members are doing really hard to keep the content up to date. So if you find this video helpful, please let us know in the comment box. Thank you. Hello everyone, welcome back to our channel. So for today's session, question is, a company's application development team uses Linux based Amazon EC2 instances as bastion hosts. Inbound SSH access to the bastion hosts is restricted to specific IP addresses as defined in the associated secretary groups. The company's security team wants to receive a notification if the security group rules are modified to allow SSH access from any IP address. So the question is, what should a DevOps engineer do to meet this requirement? Options are A. Create an Amazon event bridge rule with a source of AWS.CloudTrail and the event name. Authorize security group ingress. Define an Amazon Simple Notification Service topic as a target. Option B. Enable Amazon Guard Duty and check the findings for security groups in AWS Security Hub. Configure an Amazon event bridge rule with a custom pattern that matches Guard Duty events with an output of non-complaint. Define an Amazon Simple Notification Service topic as the target. Option C. Create an AWS config rule by using the restricted SSH managed rule to check whether security groups disallow unrestricted incoming SSH traffic. Configure automatic remediation to publish a message to an Amazon Simple Notification Service topic. Option D. Enable Amazon Inspector. Include the common vulnerabilities and exposures 1.1 rules package to check the security groups that are associated with the bastion hosts. Configure Amazon Inspector to publish a message to an Amazon Simple Notification Service topic. So the correct answer is option A. Next question is, a DevOps team manages an API running on premises that serves as a backend for an Amazon API gateway endpoint. Customers have been complaining about high response latencies, which the development team has verified using the API gateway latency metrics in Amazon CloudWatch. To identify the cause, the team needs to collect relevant data without introducing additional latency. So the question is, which actions should be taken to accomplish this? Options are: install the CloudWatch agent server side and configure the agent to upload relevant logs to CloudWatch. Option B. Enable AWS X-ray tracing in API gateway. Modify the application to capture request segments and upload those segments to X-ray during each request. Option C. Enable AWS X-ray tracing in API gateway. Modify the application to capture request segments and use the X-ray daemon to upload segments to X-ray. Option D, modify the on-premises application to send log information back to API gateway with each request. Option E, modify the on-premises application to calculate and upload statistical data relevant to the API service requests to CloudWatch metrics. So the correct answer is options B and C. Next question is, a company has an application that is using a MySQL compatible Amazon Aurora multi-AZ DB cluster as the database. A cross-region red replica has been created for disaster recovery purposes. A DevOps engineer wants to automate the promotion of the replica so it becomes the primary database instance in the event of a failure. So the question is, which solution will accomplish this? Options are A. Configure a latency-based Amazon Route 53 CNAME with health checks so it points to both the primary and replica endpoints. Subscribes an Amazon SNS topic to Amazon RDS failure notifications from AWS CloudTrail and use that topic to invoke an AWS Lambda function that will promote the replica instance as the primary. Option B. Create an Aurora custom endpoint to point to the primary database instance. Configure the application to use this endpoint. Configure AWS CloudTrail to run an AWS Lambda function to promote the replica instance and modify the custom endpoint to point to the newly promoted instance. Option C. Create an AWS Lambda function to modify the application's AWS CloudFormation template to promote the replica. Apply the template to update the stack and point the application to the newly promoted instance. Create an Amazon CloudWatch alarm to invoke this Lambda function after the failure event occurs. Option D. Store the Aurora endpoint in AWS Systems Manager parameter store. Create an Amazon Event Bridge event that detects the database failure and runs an AWS Lambda function to promote the replica instance and update the endpoint URL stored in AWS Systems Manager parameter store. Code the application to reload the endpoint from parameter store if a database connection fails. So, the correct answer is option D. Next question is, a company hosts its tagging website using an Amazon EC2 instance backed with Amazon EBS storage. The company wants to recover quickly with minimal data losses in the event of network connectivity issues or power failures on the EC2 instance. So the question is, which solution will meet these requirements? Options are A. Add the instance to an EC2 auto-scaling group with the minimum, maximum and desired capacity set to 1. Option B. Add the instance to an EC2 auto-scaling group with a lifecycle hook to detach the EBS volume when the EC2 instance shuts down or terminates. Option C. Create an Amazon CloudWatch alarm for the status check failed system metric and select the EC2 action to recover the instance. Option D. Create an Amazon CloudWatch alarm for the status check failed instance metric and select the EC2 action to reboot the instance. So the correct answer is option B. Next question is, a company wants to use AWS development tools to replace its current bash deployment scripts. The company currently deploys a LAMP application to a group of Amazon EC2 instances behind an application load balancer. During the deployments, the company unit tests the committed application, stops and starts services, unregisters and re-registers instances with the load balancer, and updates file permissions. The company wants to maintain the same deployment functionality through the shift to using AWS services. So the question is, which solution will meet these requirements? Options are A. Use AWS code built to test the application. Use bash scripts invoked by AWS code deploys appspec.yml file to restart services and deregister and register instances with the ALB. Use the appspec.yml file to update file permissions without a custom script. Option B. Use AWS code pipeline to move the application from the AWS code commit repository to AWS code deploy. Use code deploys deployment group to test the application. Unregister and re-register instances with the AL and restart services. Use the appspec.yml file to update the permissions without a custom script. Option C. Use AWS code pipeline to move the application source code from the AWS code commit repository to AWS code deploy. use code deploy to test the application, use code deploys appspec.yml file to restart services and update permissions without a custom script. Use AWS code build to unregister and re-register instances with the ALB. Option D. Use AWS code pipeline to trigger AWS code build to test the application. Use bash scripts invoked by AWS code deploys appspec.yml file to restart services. Unregister and re-register the instances in the AWS code deploy deployment group with the ALB. Update the appspec.yml file to update file permissions without a custom script. So the correct answer is option C. Next question is, a company runs an application with an Amazon EC2 and on-premises configuration. A DevOps engineer needs to standardize patching across both environments. Company policy dictates that patching only happens during non-business hours. So the question is, which combination of actions will meet these requirements? Options are A. Add the physical machines into AWS System Manager using Systems Manager hybrid activations. Option B. Attach an IAM role to the EC2 instances, allowing them to be managed by AWS System Manager. Option C. Create IAM access keys for the on-premises machines to interact with AWS Systems Manager. Option D. Run an AWS Systems Manager automation document to patch the systems every hour. Option E. Use Amazon Every Bridge scheduled events. Schedule a patch window. Option F. Use AWS Systems Manager maintenance windows to schedule a patch window. So the correct answer is options A, E and F. Next question is, a company has chosen AWS to host a new application. The company needs to implement a multi-account strategy. A DevOps engineer creates a new AWS account and an organization in AWS organizations. The DevOps engineer also creates the OU structure for the organization and sets up a landing zone by using AWS Control Tower. The DevOps engineer must implement a solution that automatically deploys resources for new accounts that users create through AWS Control Tower Account Factory. When a user creates a new account, the solution must apply AWS CloudFormation templates and SCPs that are customized for the OU or the account to automatically deploy all the resources that are attached to the account. All the OUs are enrolled in AWS Control Tower. So the question is, which solution will meet these requirements in the most automated way? Options are A. Use AWS Service Catalog with AWS Control Tower. Create portfolios and products in AWS Service Catalog. Grant granular permissions to provision these resources. Deploy SCPs by using the AWS CLI and JSON documents. Option B. Deploy cloud permission stack sets by using the required templates. Enable automatic deployment. Deploy stack instances to the required accounts. Deploy a cloud formation stack set to the organization's management account to deploy SCPs. Option C. Create an Amazon Event Bridge rule to detect the create managed account event. Configure AWS Service Catalog as a target to deploy resources to any new its accounts. Deploy SCPs by using the AWS CLI and JSON documents. Option D. Deploy the customizations for AWS Control Tower solution. Use an AWS code commit repository as the source. In the repository, create a custom package that includes the CloudFormation templates and the SCP JSON documents. So the correct answer is option B. That's all for today. Thank you everyone, and please do not forget to like and subscribe our channel, and if you find this video helpful, please let us know in the comment box. Thank you. Hello everyone, and welcome back to our channel. So today we will continue our session, but before that, please do like and subscribe to our channel, and if you find this video helpful, please let us know in the comment box. So the question is, an online retail company based in the United States plans to expand its operations to Europe and Asia in the next 6 months. Its product currently Hello everyone, and welcome back to our channel. So we will continue our session today, but before that, please do like and subscribe to our channel. So the question is, an online Hello everyone and welcome back to our channel. Today we will continue our session, but before that please do like and subscribe to our channel, and if you find this video helpful, please let us know in the comment box. So the question is, an online retail company based in the United States plans to expand its operations to Europe and Asia in the next 6 months. Its product currently runs on Amazon EC2 instances behind an application load balancer. The instances run in an Amazon. So the question is, an online retail company based in the United States plans to expand its operations to Europe and Asia in the next 6 months. Its product currently runs on an Amazon EC2 instances behind an application load balancer. The instances run in an Amazon EC2 auto-scaling group across multiple availability zones. All data is stored in an Amazon Aurora database instance. When the product is deployed in multiple regions, the company wants a single product catalog across all regions. But for compliance purposes, its customer information and purchases must be kept in each region. So the question is, how should the company meet these requirements with the least amount of application changes? Options are A. Use Amazon Redshift for the product catalog and Amazon DynamoDB tables for the customer information and purchases. Option B. Use Amazon DynamoDB global tables for the product catalog and regional tables for the customer information and purchases. Option C. Use Aurora with red replicas for the product catalog and additional local Aurora instances in region for the customer information and purchases. Option D. Use Aurora for the product catalog and Amazon DynamoDB global tables for the customer information and purchases. So the correct answer is option C. Next question is, a company is implementing a well-architected design for its globally accessible API stack. The design needs to ensure both high reliability and fast response times for users located in North America and Europe. The API stack contains the following three tiers, that is Amazon API Gateway, AWS Lambda, and Amazon DynamoDB. So the question is, which solution will meet the requirements? Options are A. Configure Amazon Route 53 to point to API Gateway APIs in North America and Europe using health checks. Configure the APIs to forward requests to a Lambda function in that region. Configure the Lambda functions to retrieve and update the data in a DynamoDB table in the same region as the Lambda function. Option B. Configure Amazon Route 53 to point to API Gateway APIs in North America and Europe using latency-based routing and health checks. Configure the APIs to forward requests to a Lambda function in that region. Configure the Lambda functions to retrieve and update the data in a DynamoDB global table. Option C. Configure Amazon Route 53 to point to API Gateway in North America. Create a disaster recovery API in Europe and configure both APIs to forward requests to the Lambda functions in that region. Retrieve the data from a DynamoDB global table. Deploy a Lambda function to check the North America API health every 5 minutes. In the event of a failure, update Route 53 to point to the disaster recovery API. Option D. Configure Amazon Route 53 to point to API Gateway API in North America using latency-based routing. Configure the API to forward requests to the Lambda function in the region nearest to the user. Configure the Lambda function to retrieve and update the data in a DynamoDB table. So the correct answer is option B. Next question is, a rapidly growing company wants to scale for developer demand for AWS development environments. Development environments are created manually in the AWS Management Console. The networking team uses AWS CloudFormation to manage the networking infrastructure, exporting stack output values for the Amazon VPC and all subnets. The development environments have common standards such as application load balancers, Amazon EC2 auto-scaling groups, security groups, and Amazon DynamoDB tables. So keep up with demand. The DevOps engineer wants to automate the creation of development environments because the infrastructure required to support the application is expected to grow. There must be a way to easily update the deployed infrastructure. CloudFormation will be used to create a template for the development environments. So the question is, which approach will meet this requirement and quickly provide consistent AWS environments for developers? So options are A. Use fn import value intrinsic functions in the resources section of the template to retrieve virtual private cloud and subnet values. Use CloudFormation stack sets for the development environments using the count input parameter to indicate the number of environments needed. Use the update stack set command to update existing development environments. Option B. Use nested stacks to define common infrastructure components to access the exported values. Use template URL to reference the networking team's template to retrieve virtual private cloud and subnet values. Use fn import value intrinsic functions in the parameters section of the root template. Use the create change set and execute change set commands to update existing development environments. Option C. Use nested stacks to define common infrastructure components. Use fn import value intrinsic functions with the resources of the nested stack to retrieve virtual private cloud and subnet values. Use the create change set and execute change set commands to update existing development environments. Option D. Use fn import value intrinsic functions in the parameters section of the root template to retrieve virtual private cloud and subnet values. Define the development resources in the order they need to be created in the CloudFormation nested stacks. Use the create change set and execute change set commands to update existing development environments. So the correct answer is option B. Next question is, a company uses AWS organizations to manage multiple accounts. Information security policies require that all unencrypted Amazon EBS volumes be marked as non-compliant. A DevOps engineer needs to automatically deploy the solution and ensure that this compliance check is always present. So the question is, which solution will accomplish this? Options are A. Create an AWS CloudFormation template that defines an AWS inspector rule to check whether EBS encryption is enabled. Save the template to an Amazon S3 bucket that has been shared with all accounts within the company. Update the account creation script pointing to the CloudFormation template in Amazon S3. Option B. Create an AWS config organizational rule to check whether EBS encryption is enabled and deploy the rule using the AWS CLI. Create and apply SCP to prohibit stopping and deleting AWS config across the organization. Option C. Create an SCP in organizations. Set the policy to prevent the launch of Amazon EC2 instances without encryption on the EBS volumes using a conditional expression. Apply the SCP to all AWS accounts. Use Amazon Athena to analyze the AWS CloudTrail output, looking for events that deny an EC2 run instances action. Option D. Deploy an IAM role to all accounts from a single trusted account. Build a pipeline with AWS Code Pipeline with a stage in AWS Lambda to assume the IAM role and list all EBS volumes in the account. Publish a report to Amazon S3. So the correct answer is option C. Next question is, a company is performing vulnerability scanning for all Amazon EC2 instances across many accounts. The accounts are in an organization in AWS organizations. Each account's VPCs are attached to a shared transit gateway. The VPCs send traffic to the internet through a central egress VPC. The company has enabled Amazon Inspector in a delegated administrator account and has enabled scanning for all member accounts. A DevOps engineer discovers that some EC2 instances are listed in the Not Scanning tab in Amazon Inspector. So the question is, which combination of actions should the DevOps engineer take to resolve this issue? Options are A. Verify that AWS Systems Manager agent is installed and is running on the EC2 instances that Amazon Inspector is not scanning. Option B. Associate the target EC2 instances with security groups that allow outbound communication on port 443 to the AWS Systems Manager service endpoint. Option C. Grant inspectors start assessment run permissions to the IAM role that the DevOps engineer is using. Option D. Configure EC2 instance connect for the EC2 instances that Amazon Inspector is not scanning. Option E. Associate the target EC2 instances with instance profiles that grant permissions to communicate with AWS Systems Manager. Option F, create a managed instance activation. Use the activation code and the activation ID to register the EC2 instances. So the correct answer is options A, C, and E. Next question is, a development team uses AWS code commit for version control for applications. The development team uses AWS code pipelines, AWS code build, and AWS code deploy for CI or CD infrastructure. In code commit, the development team recently merged pull requests that did not pass long running tests in the code base. The development team needed to perform rollbacks to branches in the code base, resulting in lost time and wasted effort. A DevOps engineer must automate testing of pull requests in code commit to ensure that reviewers more easily see the results of automated tests as part of the pull request review. So the question is, what should the DevOps engineer do to meet? Option A, create an Amazon event bridge rule that reacts to the pull request status changed event. Create an AWS Lambda function that invokes a code pipeline with a code build action that runs the tests for the application. Program the Lambda function to post the code build badge as a comment on the pull request so that developers will see the badge in their code review. Option B, create an Amazon event bridge rule that reacts to the pull request created event. Create an AWS Lambda function that invokes a code pipeline with a code build action that runs the tests for the application. Program the Lambda function to post the code build test results as a comment on the pull request when the test results are complete. Option C, create an Amazon event bridge rule that reacts to pull request created and pull request source branch updated events. Create an AWS Lambda function that invokes a code pipeline with a code build action that runs the test for the application. Program the Lambda function to post the code build badge as a comment on the pull request so that developers will see the badge in their code review. Option D, create an Amazon event bridge rule that reacts to the pull request status changed event. Create an AWS Lambda function that invokes a code pipeline with a code build action that runs the test for the application. Program the Lambda function to post the code build test results as a comment on the pull request when the test results are complete. So the correct answer is option D. Hello everyone and welcome back to our channel. Before starting the session, please do like and subscribe to our channel, and if you find this video helpful, please let us know in the comment box. So the question is, a company has deployed an application in a production VPC in a single AWS account. The application is popular and is experiencing heavy usage. The company's security team wants to add additional security such as AWS WAF to the application deployment. However, the application's product manager is concerned about cost and does not want to approve the change unless the security team can prove that additional security is necessary. The security team believes that some of the application's demand might come from users that have IP addresses that are on a deny list. The security team provides a denial list to a DevOps engineer. If any of the IP addresses on the denial list access the application, the security team wants to receive automated notification in near real time so that the security team can document that the application needs additional security. The DevOps engineer creates a VPC flow log for the production VPC. So the question is, which set of additional steps should the DevOps engineer take to meet these requirements most cost effectively? Options are A. Create a log group in Amazon CloudWatch logs, configure the VPC flow log to capture accepted traffic and to send the data to the log group. Create an Amazon CloudWatch metric filter for IP addresses on the deny list. Create a CloudWatch alarm with the metric filter as input. Set the period to 5 minutes and the data points to alarm to 1. Use an Amazon Simple Notification Service topic to send alarm notices to the security team. Option B. Create an Amazon S3 bucket for log files. Configure the VPC flow log to capture all traffic and to send the data to the S3 bucket. Configure Amazon Athena to return all log files in the S3 bucket for IP addresses on the deny list. Configure Amazon QuickSight to accept data from Athena and to publish the data as a dashboard that the security team can access. Create a threshold alert of 1 for successful access. Configure the alert to automatically notify the security team as frequently as possible when the alert threshold is met. Option C. Create an Amazon S3 bucket for log files. Configure the VPC flow log to capture accepted traffic and to send the data to the S3 bucket. Configure an Amazon OpenSearch service cluster and domain for the log files. Create an AWS Lambda function to retrieve the logs from the S3 bucket, format the logs, and load the logs into the OpenSearch service cluster. Schedule the Lambda function to run every 5 minutes. Configure an alert and condition in OpenSearch service to send alerts to the security team through an Amazon Simple Notification Service topic when access from the IP addresses on the deny list is detected. Option D. Create a log group in Amazon CloudWatch Logs. Create an Amazon S3 bucket to hold query results. Configure the VPC flow log to capture all traffic and to send the data to the log group. Deploy an Amazon Athena CloudWatch connector in AWS Lambda. Connect the connector to the log group. Configure Athena to periodically query for all accepted traffic from the IP addresses on the denial list and to store the results in the S3 bucket. Configure an S3 event notification to automatically notify the security team through an Amazon Simple Notification Service topic when new objects are added to the S3 bucket. So the correct option is option A. Next question is, a DevOps engineer has automated a web service deployment by using AWS code pipeline with the following steps. First, an AWS code build project compiles the deployment artifact and runs unit tests. Second, an AWS code deploy deployment groups deploys the web service to Amazon EC2 instances in the staging environment. Third, a code deploy deployment group deploys the web service to EC2 instances in the production environment. The quality assurance, that is QA, teams requests permission to inspect the build artifact before the deployment to the production environment occurs. The QA team wants to run an internal penetration testing tool to conduct manual tests. The tool will be invoked by a REST API call. Which combination of actions should the DevOps engineer take to fill this request? Options are A. Insert a manual approval action between the test actions and deployment actions of the pipeline. Option B. Modify the buildspec.yml file for the compilation stage to require manual approval before completion. Option C. Update the code deploy deployment groups so that they require manual approval to proceed. Option D. Update the pipeline to directly call the REST API for the penetration testing tool. Option E. Update the pipeline to invoke an AWS Lambda function that calls the REST API for the penetration testing tool. So the correct answer is option E and A. Next question is, a company is hosting a web application in an AWS region for disaster recovery purposes. A second region is being used as a standby. Disaster recovery requirements state that session data must be replicated between regions in near real time, and 1% of requests should route to the secondary region to continuously verify system functionality. Additionally, if there is a disruption in service in the main region, traffic should be automatically routed to the secondary region, and the secondary region must be able to scale up to the handle all traffic. How should a DevOps engineer meet these requirements? So, options are A. In both regions, deploy the application on AWS Elastic Beanstalk and use Amazon DynamoDB global tables for session data. Use an Amazon Route 53 weighted routing policy with health checks to distribute the traffic across the regions. Option B. In both regions, launch the application in auto-scaling groups and use DynamoDB for session data. Use a Route 53 failover routing policy with health checks to distribute the traffic across the regions. Option C. In both regions, deploy the application in AWS Lambda exposed by Amazon API Gateway and use Amazon RDS for PostgreSQL with cross-region replication for session data. Deploy the web application with client-side logic to call the API gateway directly. Option D. In both regions, launch the application in auto-scaling groups and use DynamoDB global tables for session data. Enable an Amazon CloudFront weighted distribution across regions. Point the Amazon Route 53 DNS record at the CloudFront distribution. So, the correct answer is option D. Next question is a company runs an application on Amazon EC2 instances. The company uses a series of AWS CloudFormation stacks to define the application resources. A developer performs updates by building and testing the application on a laptop and then uploading the build output and CloudFormation stack templates to Amazon S3. The developer's peers review the changes before the developer performs the CloudFormation stack update and installs a new version of the application onto the EC2 instances. The deployment process is prone to errors and is time consuming when the developer updates each EC2 instance with a new application. The company wants to automate as much of the application deployment process as possible while retaining a final manual approval step before the modification of the application or resources. The company already has moved the source code for the application and the CloudFormation templates to AWS code commit. The the company also has created an AWS code build project to build and test the application. So question is which combination of steps will meet the company's requirements? Options are create an application group and a deployment group in AWS Code Deploy. Install the Code Deploy agent on the EC2 instances. Option B. Create an application revision and a deployment group in AWS Code Deploy. Create an environment in Code Deploy. Register the EC2 instances to the Code Deploy environment. Option C. Use AWS Code Pipeline to invoke the code build job, run the CloudFormation update, and pause for a manual approval step. After approval, start the AWS Code Deploy deployment. Option D. Use AWS Code Pipeline to invoke the code build job, create CloudFormation change sets for each of the application stacks, and pause for a manual approval step. After approval, run the CloudFormation change sets and start the AWS Code Deploy deployment. Option E. Use AWS Code Pipeline to invoke the code build job, create CloudFormation change sets for each of the application stacks, and pause for a manual approval set. After approval, start the AWS Code Deploy deployment. So the correct answer is option B and E. That's all for today. Thank you everyone, but do not forget to like and subscribe our channel. Our members are doing very hard to keep the content up to date, and if you find this video helpful, please let us know in the comment box. Thank you everyone.
Welcome to our channel. Today we are covering questions and answers related to the topic AWS Certified DevOps Engineer Professional DOP. If you like this content, please subscribe our channel. To find the complete list of questions and answers, please go to the playlist link provided in the description. Let me know if you have any questions. Now let's begin. The question is, a DevOps engineer manages a web application that runs on Amazon EC2 instances behind an application load balancer ALB. The instances run in an EC2 auto-scaling group across multiple availability zones. The engineer needs to implement a deployment strategy that launches a second fleet of instances with the same capacity as the original fleet, maintains the original fleet unchanged while the second fleet is launched, transitions traffic to the second fleet when the second fleet is fully deployed, terminates the original fleet automatically 1 hour after transition. Which solution will satisfy these requirements? Option A. Use an AWS CloudFormation template with a retention policy for the ALB set to 1 hour. Update the Amazon Route 53 record to reflect the new ALB. Option B. Use two AWS Elastic Beanstalk environments to perform a blue or green deployment from the original environment to the new one. Create an application version lifecycle policy to terminate the original environment in 1 hour. Option C. Use AWS code deploy with a deployment group configured with a blue or green deployment configuration. Select the option terminate the original instances in the deployment group with a waiting period of 1 hour. Option D. Use AWS Elastic Beanstalk with the configuration set to immutable. Create an eve extension using the resources key that sets the deletion policy of the ALB to 1 hour and deploy the application. Correct answer is option C. Now the next question is, a video sharing company stores its videos in Amazon S3. The company has observed a sudden increase in video access requests, but the company does not know which videos are most popular. The company needs to identify the general access pattern for the video files. This pattern includes the number of users who access a certain file on a given day, as well as the number of pull requests for certain files. How can the company meet these requirements with the least amount of effort? Option A. Activate S3 server access logging. Import the access logs into an Amazon Aurora database. Use an Aurora SQL query to analyze the access patterns. Option B. Activate S3 server access logging. Use Amazon Athena to create an external table with the log files. Use Athena to create a SQL query to analyze the access patterns. Option C. Invoke an AWS Lambda function for every S3 object access event. Configure the Lambda function to write the file access information such as user, S3 bucket, and file key to an Amazon Aurora database. Use an Aurora SQL query to analyze the access patterns. Option D. Record an Amazon CloudWatch logs log message for every S3 object access event. Configure a CloudWatch logs log stream to write the file access information such as user, S3 bucket, and file key to an Amazon Kinesis data analytics for SQL application. Perform a sliding window analysis. Correct answer is option B. Coming to the next question, a development team wants to use AWS CloudFormation stacks to deploy an application. However, the developer IAM role does not have the required permissions to provision the resources that are specified in the AWS CloudFormation template. A DevOps engineer needs to implement a solution that allows the developers to deploy the stacks. The solution must follow the principle of least privilege. Which solution will meet these requirements? Option A. Create an IAM policy that allows the developers to provision the required resources. Attach the policy to the developer IAM role. Option B. Create an IAM policy that allows full access to AWS CloudFormation. Attach the policy to the developer IAM role. Option C. Create an AWS CloudFormation service role that has the required permissions. Grant the developer IAM role a CloudFormation action. Use the new service role during stack deployments. Option D. Create an AWS CloudFormation service role that has the required permissions. Grant the developer IAM role the IAM pass role permission. Use the new service role during stack deployment. Correct answer is option C. Stay tuned for many more videos like this. If you like our effort, please subscribe our channel and give a thumbs up. Thank you. Welcome back again to the second video of this series of questions and answers related to the topic AWS Certified DevOps Engineer Professional. If you like our content, please subscribe our channel. To find the complete list of questions and answers, please go to the playlist link provided in the description. Let me know if you have any questions. Now let's begin. The question is, a production account has a requirement that any Amazon EC2 instance that has been logged into manually must be terminated within 24 hours. All applications in the production account are using auto-scaling groups with the Amazon CloudWatch Logs agent configured. How can this process be automated? Option A. Create a CloudWatch Logs subscription to an AWS Step Functions application. Configure an AWS Lambda function to add a tag to the EC2 instance that produces the login event and mark the instance to be decommissioned. Create an Amazon Event Bridge rule to invoke a second Lambda function once a day that will terminate all instances with this tag. Option B. Create an Amazon CloudWatch alarm that will be invoked by the login event. Send the notification to an Amazon Simple Notification Service Amazon SNS topic that the operations team is subscribed to and have them terminate the EC2 instance within 24 hours. Option C. Create an Amazon CloudWatch alarm that will be invoked by the login event. Configure the alarm to send to an Amazon Simple Queue service Amazon SQS queue. Use a group of worker instances to process messages from the queue, which then schedules an Amazon Event Bridge rule to be invoked. Option D. Create a CloudWatch log subscription to an AWS Lambda function. Configure the function to add a tag to the EC2 instance that produces the login event and mark the instance to be decommissioned. Create an Amazon Event Bridge rule to invoke a daily Lambda function that terminates all instances with this tag. Correct answer is option D. Coming to the next question. A company has enabled all features for its organization in AWS organizations. The organization contains 10 AWS accounts. The company has turned an AWS Cloud Trail in all the accounts. The company expects the number of AWS accounts in the organization to increase to 500 during the next year. The company plans to use multiple OUs for these accounts. The company has enabled AWS config in each existing AWS account in the organization. A DevOps engineer must implement a solution that enables AWS config automatically for all future AWS accounts that are created in the organization. Which solution will meet this requirement? Option A. In the organization's management account, create an Amazon Event Bridge rule that reacts to a create account API call. Configure the rule to invoke an AWS Lambda function that enables trusted access to AWS config for the organization. Option B. In the organization's management account, create an AWS CloudFormation stack set to enable AWS config. Configure the stack set to deploy automatically when an account is created through organizations. Option C. In the organization's management account, create an SCP that allows the appropriate AWS config API calls to enable AWS config. Apply the SCP to the root level OU. Option D. In the organization's management account, create an Amazon Event Bridge rule that reacts to a create account API call. Configure the rule to invoke an AWS Systems Manager Automation Runbook to enable AWS config for the account. Correct answer is option B. Now the next question is, a company has many applications. Different teams in the company develop the applications by using multiple languages and frameworks. The applications run on premises and on different servers with different operating systems. Each team has its own release protocol and process. The company wants to reduce the complexity of the release and maintenance of these applications. The company is migrating its technology stacks, including these applications, to AWS. The company wants centralized control of source code, a consistent and automatic delivery pipeline, and as few maintenance tasks as possible on the underlying infrastructure. What should a DevOps engineer do to meet these requirements? Option A. Create one AWS code commit repository for all applications. Put each application's code in a different branch, merge the branches, and use AWS code build to build the applications. Use AWS code deploy to deploy the applications to one centralized application server. Option B. Create one AWS code commit repository for each of the applications. Use AWS code build to build the applications one at a time. Use AWS code deploy to deploy the applications to one centralized application server. Option C. Create one AWS code commit repository for each of the applications. Use AWS code build to build the applications one at a time and to create one AMI for each server. Use AWS CloudFormation stack sets to automatically provision and decommission Amazon EC2 fleets by using these AMIs. Option D. Create one AWS code commit repository for each of the applications. Use AWS code build to build one Docker image for each application in Amazon Elastic Container Registry. Amazon ECR. Use AWS code deploy to deploy the applications to Amazon Elastic Container Service. Amazon ECS on infrastructure that AWS Fargate manages. Correct answer is option D. Stay tuned for many more videos like this. If you like our effort, please subscribe our channel and give a thumbs up. Thank you. Welcome back again to the third video of this series of questions and answers related to the topic AWS Certified DevOps Engineer Professional DOP. If you like this content, please subscribe our channel. Thank you. To find the complete list of questions and answers, please go to the playlist link provided in the description. Let me know if you have any questions. Now let's begin. The question is, a company's application is currently deployed to a single AWS region. Recently, the company opened a new office on a different continent. The users in the new office are experiencing high latency. The company's application runs on Amazon EC2 instances behind an application load balancer (ALB) and uses Amazon DynamoDB as the database layer. The instances run in an EC2 auto-scaling group across multiple availability zones. A DevOps engineer is tasked with minimizing application response times and improving availability for users in both regions. Which combination of actions should be taken to address the latency issues? Choose 3. Option A. Create a new DynamoDB table in the new region with cross-region replication enabled. Option B. Create new ALB and auto-scaling group global resources and configure the new ALB to direct traffic to the new auto-scaling group. Option C. Create new ALB and auto-scaling group resources in the new region and configure the new ALB to direct traffic to the new auto-scaling group. Option D. Create Amazon Route 53 records, health checks, and latency-based routing policies to route to the ALB. Option E. Create Amazon Route 53 aliases, health checks, and failover routing policies to route to the ALB. Option F. Convert the DynamoDB table to a global table. Correct answer is C, D, and F. Next question is, a DevOps engineer needs to apply a core set of security controls to an existing set of AWS accounts. The accounts are in an organization in AWS organizations. individual teams will administer individual accounts by using the Administrator Access AWS Managed policy. For all accounts, AWS CloudTrail and AWS Config must be turned on in all available AWS regions. Individual account administrators must not be able to edit or delete any of the baseline resources. However, individual account administrators must be able to edit or delete their own CloudTrail trails and AWS config rules. Which solution will meet these requirements in the most operationally efficient way? Option A. Create an AWS CloudFormation template that defines the standard account resources. Deploy the template to all accounts from the organization's management account by using CloudFormation stack sets. Set the stack policy to deny, update, delete actions. Option B. Enable AWS Control Tower. Enroll the existing accounts in AWS Control Tower. Grant the individual account administrators access to CloudTrails and AWS config. Option C. Designate an AWS config management account. Create AWS config recorders in all accounts by using AWS CloudFormation stack sets. Deploy AWS config rules to the organization by using the AWS config management account. Create a CloudTrail organization trail in the organization's management account. Deny modification or deletion of the AWS config recorders by using an SCP. Option D. Create an AWS CloudFormation template that defines the standard account resources. Deploy the template to all accounts from the organization's management account by using CloudFormation stack sets. Create an SCP that prevents updates or deletions to CloudTrail resources or AWS config resources unless the principal is an administrator of the organization's management account. Correct answer is option C. Next question is, a company has its AWS accounts in an organization. In AWS organizations, AWS config is manually configured in each AWS account. The company needs to implement a solution to centrally configure AWS config for all accounts in the organization. The solution also must record resource changes to a central account. Which combination of actions should a DevOps engineer perform to meet these requirements? Choose 2. Option A. Configure a delegated administrator account for AWS config. Enable trusted access for AWS config in the organization. Option B. Configure a delegated administrator account for AWS config. Create a service linked role for AWS config in the organization's management account. Option C. Create an AWS CloudFormation template to create an AWS config aggregator. Configure a CloudFormation stack set to deploy the template to all accounts in the organization. Option D. Create an AWS config organization aggregator in the organization's management account. Configure data collection from all AWS accounts in the organization and from all AWS regions. Option E. Create an AWS config organization aggregator in the delegated administrator account. Configure data collection from all AWS accounts in the organization and from all AWS regions. Correct answer is option B and C. Stay tuned for many more videos like this. If you like this effort, please subscribe our channel and give a thumbs up. Thank you. Welcome back again to the fourth video of this series of questions and answers related to the topic AWS Certified DevOps Engineer Professional DOP. If you like this content, please subscribe our channel. To find the complete list of questions and answers, please go to the playlist link provided in the description. Let me know if you have any questions. Now let's begin with today's session. The question is, A company wants to migrate its content sharing web application hosted on Amazon EC2 to a serverless architecture. The company currently deploys changes to its application by creating a new auto-scaling group of EC2 instances and a new elastic load balancer, and then shifting the traffic away using an Amazon Route 53 weighted routing policy. For its new serverless application, the company is planning to use Amazon API Gateway and AWS Lambda. The company will need to update its deployment processes to work with the new application. It will also need to retain the ability to test new features on a small number of users before rolling the features out to the entire user base. Which deployment strategy will meet these requirements? Option A. Use AWS CDK to deploy API Gateway and Lambda functions. When code needs to be changed, update the AWS CloudFormation stack and deploy the new version of the APIs and Lambda functions. Use a Route 53 failover routing policy for the canary release strategy. Option B. Use AWS CloudFormation to deploy API Gateway and Lambda functions using Lambda functions versions. When code needs to be changed, update the CloudFormation stack with the new Lambda code and update the API versions using a canary release strategy. Promote the new version when testing is complete. Option C. Use AWS Elastic Beanstalk to deploy API Gateway and Lambda functions. When code needs to be changed, deploy a new version of the API and Lambda functions. Shift traffic gradually using an Elastic Beanstalk blue or green deployment. Option D. Use AWS OpsWorks to deploy API Gateway in the service layer and Lambda functions in a custom layer. When code needs to be changed, use OpsWorks to perform a blue or green deployment and shift traffic gradually. Correct answer is option B. Next question is, a development team uses AWS Code Commit, AWS Code Pipeline, and AWS Code Build to develop and deploy an application. Changes to the code are submitted by pull requests. The development team reviews and merges the pull requests, and then the pipeline builds and tests the application. Over time, the number of pull requests has increased. The pipeline is frequently blocked because of failing tests. To prevent this blockage, the development team wants to run the unit and integration tests on each pull request before it is merged. Which solution will meet these requirements? Option A. Create a code build project to run the unit and integration tests. Create a code commit approval rule template. Configure the template to require the successful invocation of the code build project. Attach the approval rule to the project's code commit repository. Option B. Create an Amazon event bridge rule to match pull request created events from code commit. Create a code build project to run the unit and integration tests. Configure the code build project as a target of the event bridge rule that includes a custom event payload with the code commit repository and branch information from the event. Option C. Create an Amazon event bridge rule to match pull request created events from code commit. Modify the existing code pipeline to not run the deploy steps if the build is started from a pull request. Configure the event bridge rule to run the pipeline with a custom payload that contains the code commit repository and branch information from the event. Option D. Create a code build project to run the unit and integration tests. Create a code commit notification rule that matches when a pull request is created or updated. Configure the notification rule to invoke the code build project. Correct answer is option B. The next question is, A company has an application that runs on a fleet of Amazon EC2 instances. The application requires frequent restarts. The application logs contain error messages when a restart is required. The application logs are published to a log group in Amazon CloudWatch Logs. An Amazon CloudWatch alarm notifies an application engineer through an Amazon Simple Notification Service Amazon SNS topic when the logs contain a large number of restart related error messages. The application engineer manually restarts the application on the instances after the application engineer receives a notification from the SNS topic. A DevOps engineer needs to implement a solution to automate the application restart on the instances without restarting the instances. Which solution will meet these requirements in the most operationally efficient manner? Option A. Configure an AWS System Manager automation runbook that runs a script to restart the application on the instances. Configure the SNS topic to invoke the runbook. Option B. Create an AWS Lambda function that restarts the application on the instances. Configure the Lambda function as an event destination of the SNS topic. Option C. Configure an AWS Systems Manager automation runbook that runs a script to restart the application on the instances. Create an AWS Lambda function to invoke the runbook. Configure the Lambda function as an event destination of the SNS topic. Option D. Configure an AWS Systems Manager automation runbook that runs a script to restart the application on the instances. Configure an Amazon Event Bridge rule that reacts when the CloudWatch alarm enters alarm state. Specify the runbook as a target of the rule. Correct answer is option D. Stay tuned for many more videos like this. If you like this effort, please like and subscribe our channel. Thank you. Welcome back again to the fifth video of this series of questions and answers related to AWS Certified DevOps Engineer Professional DOP. If you like this content, please subscribe our channel. To find the complete list of questions and answers, please go to the playlist link provided in the description. Let me know if you have any questions. Now let's begin. The question is, a DevOps engineer at a company is supporting an AWS environment in which all users use AWS IAM Identity Center, AWS Single Sign-On. The company wants to immediately disable credentials of any new IAM user and wants the security team to receive a notification. Which combination of steps should the DevOps engineer take to meet these requirements? Choose 3. Option A. Create an Amazon Event Bridge rule that reacts to an IAM Create User API call in AWS CloudTrail. Option B. Create an Amazon Event Bridge rule that reacts to an IAM Get Login Profile API call in AWS CloudTrail. Option C. Create an AWS Lambda function that is a target of the Event Bridge rule. Configure the Lambda function to disable any access keys and delete the login profiles that are associated with the IAM user. Option D. Create an AWS Lambda function that is a target of the Event Bridge rule. Configure the Lambda function to delete the login profiles that are associated with the IAM user. Option E. Create an Amazon Simple Notification Service Amazon SNS topic that is a target of the Event Bridge rule. Subscribe the security team's group email address to the topic. Option F. Create an Amazon Simple Queue Service Amazon SQS queue that is a target of the Lambda function. Subscribe the security team's group email address to the queue. Correct answer is option A, C and E. Next question is, a company wants to set up a continuous delivery pipeline. The company stores application code in a private GitHub repository. The company needs to deploy the application components to Amazon Elastic Container Service, Amazon ECS, Amazon EC2, and AWS Lambda. The pipeline must support manual approval actions. Which solution will meet these requirements? Option A. Use AWS Code Pipeline with Amazon ECS, Amazon EC2, and Lambda as deploy providers. Option B. Use AWS Code Pipeline with AWS Code Deploy as the deploy provider. Option C. Use AWS Code Pipeline with AWS Elastic Beanstalk as the deploy provider. Option D. Use AWS Code Deploy with GitHub integration to deploy the application. Correct answer is option A. Next question is, a company has an application that runs on Amazon EC2 instances that are in an auto-scaling group. When the application starts up, the application needs to process data from an Amazon S3 bucket before the application can start to serve requests. The size of the data that is stored in the S3 bucket is growing. When the auto-scaling group adds new instances, the application now takes several minutes to download and process the data before the application can serve requests. The company must reduce the time that elapses before new EC2 instances are ready to serve requests. Which solution is the most cost-effective way to reduce the application startup time? Option A. Configure a warm pool for the auto-scaling group with warmed EC2 instances in the stopped state. Configure an auto-scaling EC2 instance launching lifecycle hook on the auto-scaling group. Modify the application to complete the lifecycle hook when the application is ready to serve requests. Option B. Increase the maximum instance count of the auto-scaling group. Configure an auto-scaling EC2 instance launching lifecycle hook on the auto-scaling group. Modify the application to complete the lifecycle hook when the application is ready to serve requests. Option C. Configure a warm pool for the auto-scaling group with warmed EC2 instances in the running state. Configure an auto-scaling EC2 instance launching lifecycle hook on the auto-scaling group. Modify the application to complete the lifecycle hook when the application is ready to serve requests. Option D. Increase the maximum instance count of the auto-scaling group. Configure an auto-scaling EC2 instance launching lifecycle hook on the auto-scaling group. Modify the application to complete the lifecycle hook and to place the new instance in the standby state when the application is ready to serve requests. Correct answer is option C. Stay tuned for many more videos like this. If you like our channel, please subscribe it and give a thumbs up. Thank you. Welcome back again to the sixth video of this series of AWS Certified DevOps Engineer Professional DOP questions and answers. If you like this content, please subscribe our channel. To find the complete list of questions and answers, please go to the playlist link provided in the description. Let me know if you have any questions. Now let's begin with today's questions. A company is using an AWS code build project to build and package an application. The packages are copied to a shared Amazon S3 bucket before being deployed across multiple AWS accounts. The buildspec.yml file contains the following: version 0.2, phases, build, commands, go, build, o, myapp, post underscore build, commands, AWS S3 CP, ACL, authenticated, read, myapp S3 : artifacts. The DevOps engineer has noticed that anybody with an AWS account is able to download the artifacts. What steps should the DevOps engineer take to stop this? Option A. Modify the post build command to use ACL public read and configure a bucket policy that grants read access to the relevant AWS accounts only. Option B. Configure a default ACL for the S3 bucket that defines the set of authenticated users as the relevant AWS accounts, only the grants read-only access. Option C. Create an S3 bucket policy that grants read access to the relevant AWS accounts and denies read access to the principal. Option D. Modify the post build command to remove ACL authenticated read and configure a bucket policy that allows read access to the relevant AWS accounts only. Correct answer is option D. Next question is, a company has developed a serverless web application that is hosted on AWS. The application consists of Amazon S3, Amazon API Gateway, several AWS Lambda functions, and an Amazon RDS for MySQL database. The company is using AWS Code Commit to store the source code. The source code is a combination of AWS Serverless Application Model (AWS SAM) templates and Python code. A security audit and penetration test reveal that usernames and passwords for authentication to the database are hard-coded within code commit repositories. A DevOps engineer must implement a solution to automatically detect and prevent hard-coded secrets. What is the most secure solution that meets these requirements? Option A. Enable Amazon Code Guru Profiler. Decorate the handler function with @ with Lambda Profiler. Manually review the recommendation report. Write the secret to AWS Systems Manager parameter store as a secure string. Update the SAM templates and the Python code to pull the secret from parameter store. Option B. Associate the code commit repository with Amazon Code Guru Reviewer. Manually check the code review for any recommendations. Choose the option to protect the secret. Update the SAM templates and the Python code to pull the secrets from AWS Secrets Manager. Option C. Enable Amazon Code Guru Profiler. Decorate the handler function with @ with Lambda Profiler. Manually review the recommendation report. Choose the option to protect the secret. Update the SAM templates and the Python code to pull the secrets from AWS Secrets Manager. Option D. Associate the code commit repository with Amazon Code Guru Reviewer. Manually check the code review for any recommendations. Write the secret to AWS Systems Manager parameter store as a string. Update the SAM templates and the Python code to pull the secret from parameter store. Correct answer is option C. That's it for today. Stay tuned for many more videos like this. If you like our effort, please subscribe our channel and give a thumbs up. Thank you.